Newton's laws of motion are simple physical laws that have set the foundation for classical mechanics. Every single thing we see moves in relationship with Newton's laws. And it's thanks to these laws, engineers have been able to explain how buildings don't fall over, how cars can move, and how aircrafts can fly. Newton's second law states that the resultant force on an object is equal to the mass of the object times the acceleration in the direction of the resultant force. Let's look at an example where a football is being kicked in this direction. The acceleration is 15 meters per second squared and the mass is 0.5 kilograms. We can calculate the resultant force using Newton's second law by doing F equals ma, which is 15 times 0.5, which gives us 7.5 newtons. Newton's third law states that every force has an equal and opposite force acting against it. A simple example would be headbutting a wall. When you headbutt a wall with a certain amount of force, the wall exerts an equal and opposite force on your head. Let's combine these two laws into a more complex scenario. Here we have a truck of mass 200 kg pulling a trailer of mass 50 kg through a light inelastic rope. Knowing the mass and acceleration of the truck, we can apply Newton's second law to calculate the resultant force, which gives us 1000 newtons. We can now use this resultant force along with the driving force and the friction on the tires given to calculate the tension on the rope due to the trailer pulling the truck backwards, which gives us 400 newtons. We can now apply Newton's second law on the trailer to calculate its resultant force, which will be 250 newtons. Now, Newton's third law tells us every force has an equal and opposite reaction force. This must mean that the tension on the rope pulling the trailer forwards is also 400 newtons. We now have all the information needed and we can calculate the friction on the tires, which is 150 newtons.